All right, thank you very much. So before we get started, I want to introduce Mr. James Juniper. He's a solutions architect with the Geo Community Cloud for Natural Resources Canada. He'll be talking a little bit about some of the customer use cases for some of the things that I'll be talking about today as far as the architecture design of building data lakes and analytics. So myself, I'm a senior solutions architect with Amazon Web Services within the public sector practice. I work with customers on designing their data supply chain architecture, so everywhere from consumption, ingestion, all the way to the end state, which is going to be your analytics users. So today we're going to talk about the first part of that, which is going to be your data lakes and how to use AWS analytics to enable your organization. So challenges with big data today. I mean, everybody's probably seen these slides before, right? Volume, velocity, variety, veracity, value, and all the things that come around with big data. And really what AWS enables you to do is to manage all of these in a way that's really never been possible at scale before. I always like to tell people I'm kind of a space nerd, big fan of the space program. And if you look at what NASA was doing in the 60s with just a very little bit of data, you know, and I'll show you a slide in a minute that kind of illustrates that and how far we've come today with just the volume, you know, the amount of data processed from, say, you know, when they first put a man on the moon, the velocity of data, how fast it's coming at you now, everything from your cell phone to your refrigerator to your door chime. You know, you're basically getting data from all over the place now. The variety of data, right? I kind of mentioned the velocity, but you're getting it from everywhere. And then probably the most important thing that I find is the veracity of data. How accurate is the data? Everybody says, well, it's bad data or it's good data. Data is just data. And it's up to you to determine, is it relevant to your business? Are you getting good data in that's accurate, and is it relevant to your business? And then is it providing value, right? That's the other challenge. You're inundated with so much data today. Are you able to derive the value out of that data for your organization? So I talked a little bit about, NASA in the 60s, and if you look at data growth, it's exponentially. Not only is it exponentially, it's accelerating at an incredible pace, where if you look at some of our, reference customers like Netflix, and, they're in the petabytes and going on to the exabyte scale. So, how do you store all that data efficiently? How do you store it economically? How do you plan for future growth without having any idea of what that future growth is going to look like? Then there's the increasing variety of data as well. IoT devices, I mentioned, refrigerators and door chimes and whatever else is there that's consuming data in the environment today. So an AWS data lake, or your data lake in AWS, helps you address this by allowing you to ingest and store any type of data out there, right? I don't really care what type of data it is. I just want to be able to store it and make it available for the community of interest. I want to run the right tool for the right job, without having to manually copy data around. And so one of the big principles is make your organizational users come to the data. Don't have your data passed out all over the place. Because one of the reasons for not doing that is the accuracy of it. If you tell somebody a secret and they go around the room 30 times, the information ends up different by the time it gets to the last person. It's kind of the same thing with data. If you start copying it around, you incur costs. There's all sorts of things associated with that you can enable. You don't have to do now that you have your data in a data lake. And insights and security together. So we always say at Amazon, security is job zero, right? We wouldn't be in this business if we didn't have a very secure platform, both encryption data at rest, in transit, here are identity access management policies that govern data. It's the most important thing we do, because if a customer doesn't trust us with their data, then there's no business. And so security is not job one for us, it's job zero. So data lakes on AWS. You have, your ingestion. You have traditional data movement. Think about your RDBMSs, your Oracles out there, your SQL servers, your MySQLs. None of that stuff's going away. It's not, the relational database world, the COTS products that are out there that are all built on that are going to be around for a while, let's face it. I mean, there's, huge implementations of SAP and Oracle products, all of which, by the way, run on AWS. But then you also have real-time data movement. So a lot of your IoT devices, we look at some of the stuff I work in is in satellite communications. So things that are actually flowing in real time in your environment. How do you handle both types of data, both economically and at scale? Cataloging your data, I'll talk about that a little bit more, is very important. And it's also something that's overlooked as part of this process is what do we have? And then the intelligence part of it is machine learning. Everybody wants to talk about machine learning, But machine learning is a huge field, right? There's all sorts of different things, but what do you have to do good machine learning, good quality data? You talk to anybody internally at AWS, the guys that run Lex, which is Alexa is built off of, or any of our services, and they all tell you the same thing. None of that works without good quality data. Analytics, right? Just people doing business intelligence, reporting, any of that stuff. How do you do that? If you'll notice, one of the things that's really is decoupling your analytics from your storage, catalog, and your data. So if you look at it from the perspective, one of the things I talk about in another presentation I do on data pipelines is analytics as a service, or bring your own analytics. What having a lake allows you to do is allow your customer base, your organization, whether it's internal, external customers, to bring their own tool sets. So they might want to use an AWS tool. They might want to use a Redshift or an EMR. They also might want to use Tableau. They might feel comfortable with, Toad for Oracle or something along those lines. But it allows you to diversify your tool set so you don't have to force anything onto your users. They can use whatever tool that they're comfortable with. So what data do I have? This is the most important question that goes unanswered. So metadata is the fish in the data lake. It tells you what data you have. One of the things I talk about when consuming data from customers is building memorandums of agreement or understanding with data trading partners so that I can understand what is it that I'm getting, right? Without understanding what I'm getting, I can't catalog it, but two, I can't relate it to other data that I'm getting in, which is really the value of it, right? It's not just the individual data sets, but how does that value and the other data relate across my organization, or allows me to look at insights that may have never been able to find before. So AWS Glue is our service that allows you to catalog that data. Through a process of crawling the data, it allows you to go through and extract metadata out of that data. So if you have data, you can predefine it in Glue. You can build your own custom data, or you can allow the data catalog to go through that. We also have a huge ecosystem of partners that are actually building, different user interfaces and different capabilities on type of the Apache Hive Metastore on which you can store your data catalog, which is really interesting. And I'm starting to work a lot with customers on the visualization of that data catalog. So not only allowing them to consume information, but also allowing them to visualize it to extract out to the broader community of interest. So if I'm looking for a particular set of data, I can use normal search type capabilities in order to do that. So what can the crawler discover? Well, pretty much anything. You can, traditional RDBMSs. So, most of your major, MySQLs, Postgres, Auroras, Oracles, Amazon Redshift. I'll talk about our data warehousing service in a minute. DynamoDB. And then S3, which is actually probably one of our most common things. So if you're using S3 as your landing zone for all of your data lake, we can really search it with any format out there. To be honest, most stuff's kind of in a delimited format today. If you're extracting stuff from legacy systems, some might send you a pipe delimited or comma delimited. We can crawl all of that and consume it into a data catalog. It's a basic JDBC connection. There's nothing fancy about doing it. You can actually build your own custom classifiers if you want to, through regular expressions. XML tags, JSON, if any of those things you're able to build your own. So there's a lot of pre-built capabilities, but it also allows you to customization to look at your data from a holistic standpoint to be able to figure out what is the best fit for use, fit for purpose. So you can create tables manually in AWS Glue through DDL statements. You could use the API just like you can any other AWS service, or you can integrate with the Hive Metastore. The Hive Metastore is actually what a lot of our partner product in our marketplace, our AWS product partners are doing to integrate with Glue. So it gives you a lot of flexibility to not just do it automatically, but also create your own. So how do I hydrate my data lake? So I have traditional data movement, right? We have different ways. We have direct connect. If you're not familiar with that, it's just a direct connection into the cloud. Physical connection. We have our AWS Snowball. If you're not familiar, I use the Snowball quite a bit for a lot of different reasons. So Snowball is a device to move mass amounts of data. So it's not the AWS network that's usually the challenge. It's usually the customer network to AWS. So if you've got to move 20, 30, 40, 50 terabytes of data, you're probably going to use a Snowball. We've had customers who have moved whole data centers, petabytes of data, using what's called a Snowmobile, which is a 53-foot tractor trailer container. So we can move the data. That's not an issue. Our database migration service, if you're connected to AWS or you want to use a Snowball and you want to do more of a real-time CDC, you could use that. But But there's a lot of other ways to do that. You could use, if you're an Oracle user or a SQL Server user, you can also use some native capabilities to do that as well, to get it into your data lake. It's really whatever's fit for the correct job. Real-time data movement, IoT devices. If you guys aren't familiar with Kinesis, it's real-time data movement. So you've got Firehose, which is allows you to integrate automatically with other AWS services. So S3. Redshift, and a few other ones that you don't configure anything. It actually expands and contracts as you stream the data. We have AWS Kinesis data streams, which has APIs and other interfaces to do more things programmatically. We can also have video streams. So if you're doing pulling in audio and video, and you want to do somewhat of a pipeline where you want to separate audio and video and do some kind of textual analysis, we can do that as well through some of our other partners. So I kind of mentioned, what is, dedicated from an on-premise. Like, how do I get my data? So you could have a dedicated network connection. You could do a VPN firewall into AWS. You could do direct connect. You could do however you wanted to through secure, appliance. The ruggedized shipping container, which I mentioned, our Snowball, database migration. You could even use file gateway if you wanted to. If you wanted to do it more of a kind of file server, probably some of the stuff they talked about in the last session, more of backup and recovery type solution. Data movement from real-time sources through streams or video streams. The point being is using S3 as the basis for your data lake, we could pretty much accommodate anything at this point. I've worked, all over the, worldwide public sector, and there's not anything that I haven't seen that we couldn't accommodate. So real-time data movement, I kind of talked about Kinesis. You can use the producer library, which is, allows you, it's not 100% programmatic. It allows you some interfaces. We have an agent. But we also have other sources that you can also tap into a Kinesis stream into your data lake. It also allows you to do catalog your data and do some real-time analytics on your stream as it's coming in. So you think about AWS, Amazon.com, like clickstream events and, sales and all the different things that you want to see in real time to make changes to your organization, strategic, tactical decisions in your organization in more of a real time. That's what you're going to do, some kind of streaming analytics against that. So all sorts of ways to do that. There's hundreds and hundreds of use cases of different reasons why you might want to do that. But again, the defining is Glue, cataloging your data, and S3 as your landing zone for your data lake. So one of the key concepts of this is you're able to ingest your data in its raw form. So I don't have to transform anything. I don't have to do anything to the data. I can just pull it in. Now you might want to do some other transformations downstream, what I'll address in a minute, where you're applying maybe some quality rules or things like that to the data. But really what it becomes is your source of record. And so if you've processed the data downstream and you need some type of, for either compliance reasons or some other reason that you need to go all the way back to the source, you're able to do that. So you're able to ingest it in its raw form. You might even want to lifecycle it off to Glacier, so I can keep it in my raw form, but I'm going to do some type of transformation to make it consumable by my customers downstream. Lifecycle policies allow you to do that, but it also allows you to maintain retention. We see that a lot for compliance in the U.S., for have to retain emails for X amount of time, or other reasons. You might even find an error in the data that you want to take back to the system of record, and you might find that error downstream that you want to trace all the way back to the source file to take back to the system of record. We're talking about a source of truth is the data lake, but the systems of record are what feed it. And you might need to go back to that person to show the data lineage and the fact that this information is wrong. So it allows you to do this without any transformations on the data coming in. So I talked a little bit about the tiered storage. S3, we have infrequent access. So really depending on your use case of the data and how often you need access to it, we have different service features and functionalities that allow you to do that. Kind of the high end being S3 and the back end being Glacier. So if you want to you want to store all this data forever, and honestly, that cost has probably come down. You can store it for less than a penny a gigabyte a month. So really the value of storing that data, it really doesn't hold value to get rid of it anymore. So you really don't have to get rid of any of your data. You can always go back to it. We actually use that a lot for, I need to take a backup of my database once a month. My database is 20 terabytes or whatever it is, 30 terabytes. I can back my database up to S3 and then put it on Glacier, and I can keep that indefinitely. Raw data sets. immutable data sets that you can always go back to, kind of discuss that a little bit. Abstract out the complexities of how the data is stored. S3, I don't care how it's stored. It's object storage. I know it's always going to be there. Then I can also curate those data sets after I've got the raw data to optimize consumption based on the tool set, right? Depending on the tool I'm using, I might want to put it in a different file format. I might want to add some quality to it. There's all sorts of things. There's really no limit as to what you can do to it. And that's a typical practice that I work with customers in some of this data supply chain stuff is taking raw data and applying quality rules, not necessarily business rules. So validating that an address is an actual address, or that in the US, the example is Social Security numbers has to be 9 digits. And then if I find errors in those, I will push those off as an outlier and take those back to the system of record owner to find out what's going on with that. But what it's doing is it's abstracting that process from your data consumer so that your data scientists in that community doesn't have to do that work anymore. They know when they get the data set that it's going to be accurate data and it's going to be quality data. So raw data, kind of that process, you're really taking the raw data, you're normalizing some of it, you may partition the data, you may compress it. It's an ETL process, or an ELT process in this case, into curated data sets. So I'm taking my raw data and I'm transforming it into a consumable format using something like a glue. I've seen customers use Lambda. There's other options to do that. And I'm cataloging both sets. So I've got consistency across being able to trace that data from its raw format into its curated format. So which tool should I use to analyze my data? You can use any tool you want to. That's kind of the beauty of this. So Amazon's got a huge portfolio of analysis tools. So Athena, Elastic MapReduce, Redshift, Elasticsearch, QuickSight. Pretty much, from a bring your own analytics model or an analytics as a service model, we can cover all that. So whatever your user is comfortable with, if they're a Hadoop user, and they're comfortable with Spark, they can use EMR. If they're comfortable with Hive or Pig or anything that can sit on top of Yarn. If they're more SQL oriented, right, they want to do more traditional data warehousing, they know ANSI SQL, then Redshift might be a better solution for them. Athena, again, is a you pay by the query. You can SQL the data or query the data directly. So different tools for different users, and that's really the beauty of the system. My data doesn't move. It always stays in the same place, but I can access the data in its original state from any of these tool sets. I can use SageMaker if I want to build machine learning models. I could install my own EC2 instance with Python on it if I wanted to. Really don't care, right? I'm looking at it from a business reporting perspective, which I kind of call my retail users, all the way to my wholesale users, which I would refer to my data scientists and data engineers. It allows them the flexibility to use any tool set they want to against the same data set. And so I know when I'm getting results, or I'm asking questions or variations on that questions, I'm asking it against the source of truth to that data. It's actually a pretty big challenge across industry now within the federal sector, but also in the commercial. Depending on where I ask the question, I might give a different answer. Very hard to make decisions like that. And so this relegates a lot of those issues. So Athena, it's interactive analysis. It just allows you to query the data directly in an S3 bucket. I won't go through all of this in the interest of time, but it's, if I just want to run some queries against the data just to see what's in there, I can use Athena. I don't have to spin up anything. It's just paid for by the query. EMR is our managed Hadoop service. So, Hadoop's, been out in the ecosystem quite a bit now. It allows you, big data processing. So any of the stuff that generally you can run on Hadoop, so I mentioned, Spark, or, you can run MXNet on Hadoop now if you want to even do deep learning on the Hadoop framework. Any of that stuff. One of the interesting things that we've put in here, though, is the fact that you can use, instead of HDFS on the back end, you can use S3 as part of our EMR file system feature. And so instead of having to spin up Hadoop HDFS service to store the data, you can actually access it directly in an S3 bucket. It allows you to do some really interesting things now. It allows you to create transient, or what I call ephemeral EMR clusters. I don't have to bide time, or I'm not locked into hardware of a single Hadoop cluster anymore. What I'm able to do is, let's say I've got 10 data scientists, they can spin up their own Hadoop clusters, run it for however often they want to, and then spin it back down. I can templatize it with CloudFormation so that I can put some constraints around it so they don't go spin up 1,000 nodes. One of the interesting things in AWS, we do have some soft limits on things, just kind of to your protection, so somebody doesn't go just spin up 1,000, something or other, but you can always take those off. We've had customers spin up thousands of nodes for HPC processing using spot instances. So they went out in the marketplace and they said, I want to bid on capacity. And as that bid went down to met their price point, their clusters expanded. So through application auto-scaling, you can do that with EMR if you wanted to. If you had something that was more interactive, but you can scale and contract it on demand. And so it really gives you a flexibility that you would never be able to do in an on-premise environment. You think about it, you'd have to buy hardware and rack and stack it and configure it and all that stuff. I actually was at a customer last week doing a demo for this, for ephemeral transient clusters, and I actually had one had several of them up and running in less than 5 minutes. I can expand and contract it on demand. I can do all sorts of interesting things, and I'm not limited by resources anymore. So Redshift is actually our data warehousing solution. It's a massively parallel processing SQL engine behind the scenes. So it's regular SQL work. It's actually one of my favorite services because I come from the database world. But I can scale it out to petabytes and petabytes of data. So if you think about a traditional data warehouse model, your star and snowflake schemas, that's what it's designed to be efficient at. It'll pretty much outperform anything on the market as far as an RDBMS today. You can scale it out to petabytes of data. Again, the other interesting thing too is you can actually hit S3 directly from it. So I can spin up multiple clusters in an ephemeral way depending on what the customer, what my end user wants to do. So if I have a data science team or a BI team, I could spin up I could spin up clusters on demand to allow them to do their job without overlapping or conflicting with anybody else. There's no longer a serial pipeline for resources anymore. So data warehousing, I just kind of talked about Redshift. You can use your existing BI tools. It's a JDBC connection. So anything that you can connect, we have lots of customers that use Tableau and MicroStrategy, and in addition to our own QuickSight service. So there's anything you could connect to it today, or anything that you can connect through a typical SQL interface you can use today. Lots of use cases for it. I have a lot of customers where as part of my pipeline projects where I'm building out, taking it from the data lake into the warehouse. But I'll talk about why those are not mutually exclusive things. So a data lake is complementary to your data warehouse, right? People think, I've got to have one or the other. It's really not. So, it's a schema on read versus schema on write. And that means that typically, when I'm pulling data out of a data lake, I'm applying some structure to it, right? Because I want the flexibility to apply structure when I need it. Whereas a typical data warehouse, you've got a schema built in, right? You've got rows and columns and it's already predefined. Yeah, there's performance trade-offs in both. And so, but what you're finding is that gap is really starting to close, especially with some of these services. We've got some pretty interesting data on some of the speeds that we could do things like using, deploying or querying directly from S3 versus just querying from like an RDBMS or a Redshift directly from HDFS, for instance. Typically, your data lake is going to be all your semi-structured and unstructured data. Semi-structured is kind of up in the air as to what that definition. Unstructured is going to be more like your audio, video, things that don't have a natural textual structure to them. Data warehouses tend to be more structured data, right? Fast ingestion versus, it's longer to load a warehouse, but sometimes it's easier to get out. But the point of this is just saying is they're complementary. And so typically you're going to build a data warehouse off of your data lake. Your data lake's going to be everything. Your data warehouse is going to provide the business context of relationships. Think about foreign keys for those of you in the RDBMS community, for relationships between the data. So it's more about the business context at that point. Redshift Spectrum, I mentioned that. You can query directly from S3, so you can use Redshift directly in its own data store, or again, like EMR file system, you can query directly from your data lake. A lot of flexibility in that. I can also join across both. So I could have stuff in my Redshift cluster and also join that to data that's existing in my S3 bucket. So it gives you a lot of flexibility there. So this just kind of gives you a high level of looking at Redshift all the way down through the lake using Spectrum. It's easy to set up. You can set these up in 5 to 10 minutes. I can get it going. I've got examples that I show in front of customers. I've got a bunch of flight data in a bucket that I can spin this up and start querying it in less than 10 minutes. So point being, it's flexible. Just like EMR, you can expand and contract your clusters. You can have ephemeral clusters versus persistent clusters. You might have a persistent cluster if you have a strategic dashboard, let's say, and you want to keep that cluster up so that the CEO or the president of your organization walks in and wants to see this report every morning. But you also might have ephemeral clusters that I mentioned that are more for tactical questions. You know, somebody comes, and kind of an interesting dynamic is somebody could actually come and ask you a question to answer something, and you could really go back to them and say, well, how important is it? I can do it, and I can answer that in a day, or I can answer that in a minute, I can answer that in a week. It depends how many resources you want to throw at it. So it kind of creates an interesting dynamic in that sense, that it gives you a lot of flexibility again. So this is just kind of finally how everything kind of fits together. Your data warehouse is going to be typically your OLTP, ERP systems, your CMRs or CRMs, and then your data lake is going to be your devices, web traffic sensors, social media feeds. But quite frankly, I also see a lot of customers now doing extracts of their OLTP systems or typical transactional systems in some kind of delimited format. You're typically not going to put it in a JSON or an XML, it's be too heavy. But taking all their data into a limited format and also putting that in their data lake so that they're able to link all of that information together. And that's really the power of this that you've probably never been able to do before. So machine learning and big data, more data, better decisions, better products. Machine learning is driven by data, right? Either structured or supervised or unsupervised learning. The more data you have, the more accurate your models are going to be. It's pretty much that simple. The better data you have, the more accurate models you're going to be. So within our machine learning catalogs, if you guys, SageMaker allows you to build and deploy models as an API, so you can decouple that from your applications. We have a lot of deep learning APIs, particularly TensorFlow, MXNet we offer, Recognition, Lex, Chatbot, DeepLens. Comprehend is really interesting to me because I deal a lot in the kind of the textual analytics space. And so one of the things to me is to be able to take textual analytics. So if you think about it in the terms of healthcare, a doctor takes a lot of notes, right? And you want to be able to do an analysis of those notes and link that back to the structured data in a way that somebody can come in and look at that without having to do those textual analytics. We're also looking at that in logistics and repair. So somebody repairs something and they take notes about it. So really linking textual components to what you'd consider structural components, so typical rows and columns and things like that. Translate, we're adding languages constantly to AWS Translate. Internally, I get emails every other day about we've added some, not only languages, but dialects within languages as well. So it's really interesting the speed that Translate's really caught on. Transcribe, converting voice to text. And so you can kind of tell if you look at that, there's a pipeline of machine learning services that you can utilize in addition to rolling your own. You might, like I said, you might just want to roll a Jupyter notebook, run MXNet yourself for like a deep neural network, deep learning models. But we also offer a host of services that can access your data lake to build those business relationships. So I want to leave some time for our guest speaker here. So in summary, data lakes and data warehouses complement each other. If anybody's interested afterwards, I can take some questions on some of the pipeline stuff that we're working on, but remember, they're not mutually, they don't replace each other. Loosely coupled, but highly performant. So really what I'm doing is I'm decoupling my storage, my lake from all of my analytics platform. One doesn't affect the other. I'm future-proofing my analytics by not putting myself siloing myself into a particular product set or a particular format, proprietary format or anything like that. It allows me to choose the best tool for the job or allows users the path of least resistance to come in and use the data lake. So they can use tools that they're already familiar with. You don't have to go, it's the carrot versus the stick. You've got all this data, here, come in your tool and use it. Elasticity, multiple clusters for dedicated purposes. We talked about that a lot in the ephemeral, transient clusters versus permanent clusters and the use cases for both. I can replace capacity planning with a consumption model. If I'm using S3, there is no capacity planning. It's just growing, right? I just put data in there and it gets bigger and bigger and bigger and bigger. I can mix it, I can use different folders, I can structure it differently so that I'm able to segregate the data by security policies and other things like that if I want to. But I don't have to go out and I don't have to predict SAN storage. I don't have to go buy arrays anymore or anything like that. I just put it in my bucket. So I'm shifting from a value proposition. I'm able to focus more on the use cases versus the underlying infrastructure. Don't forget about metadata management. It's the one thing, it's not the cool, machine learning and everybody wants to talk about it, but it's critical to do good metadata management for your end users so that they know what they have. Use right storage tier in the data format. Data structures, fixed schema, JSON, key values, access patterns. Store the data in the format you will access it. You can store the same data in multiple formats if you want to. There's lots of, flexibility, agility to be able to do that. And then you can look at the data characteristics as to how you want to store your data. We talked about, S3 being kind of the high end of that. I've got data that I need access to in real time, all the time, from anywhere, S3. And I might want to, all the way to Glacier, or I need to archive this data, right? I only need it for, auditability purposes. And then you can optimize the cost. That's one of the things that I work with customers a lot in building cost-benefit analysis of why is this valuable? So what that I'm saving money, or so what that I can run this query X times faster? How does that affect the business? And that's, optimizing solution, optimizing the cost. So I will be around to take questions afterwards, but I want to turn the mic over. Thank you, sir. Let me know if you need anything.
Well, good afternoon, everyone. I'd like to thank AWS for inviting me to speak here today, and it's good to see all of you, and I've bumped into a number of colleagues, both past and present, here today. My name is James Juniper. I'm with the Federal Geospatial Platform. I'm here to speak about a slightly different topic, though, today, which is our Geo Community Cloud initiative. And this is something we've been working on going on 2 years now. We're getting close every day. We are on AWS as we speak in a sandbox and dev environment. So we'll talk a little bit about that, but perhaps more importantly, I'll share some thoughts today about big data and big data in the context of Earth observation in particular, because I work for the Canada Centre for Remote Sensing and Earth Observation. That's the branch that the FGP fits under, and of course that's a big topic for us, and I'd like to share a bit of that context with you today. Oops, wrong button. So just a little bit briefly about the Federal Geospatial Platform. So we like to think we're the leader in geospatial for the Government of Canada. What we've done over the history of the project, we were in a project phase for about 4 years, operations into the second year now. Essentially what we do is make available AAA quality government data so that it can be leveraged and used in accessible formats and make that readily discoverable, which has always been a problem, it seems, going back historically. So accessible data, available data, and authoritative data, that's the third A. By authoritative, I mean it has legitimacy, it has metadata. Stephen talked a bit about the importance of that. Of course, it's a bit of a snore topic for some. Other people really get jazzed up about it, but regardless, I think nobody questions that it's a valuable attribute, and without metadata, you really don't have any way of understanding the quality of the data that you're dealing with. In terms of the delivery of that data, we've adopted a standards approach. So we use ISO 19115, which is the North American Profile Standard of metadata, Open Geospatial Consortium standards to make data exchange interoperable. Excuse me, and RESTful web services is a way to put an interactive map in your browser very simply with only a few lines of code. We have a catalog, and Stephen also talked about the importance of cataloging. All this metadata is contained in a searchable and discoverable catalog that you can access from the public through the internet on open maps, or internal to the government on the GC intranet at gcgeo.gc.ca. The reason that there's two, we have some publishing clients who prefer to keep some data sets to an internal Government of Canada only audience, but the vast majority are open data. We have approximately 950 data sets that meet that AAA standard currently today. In terms of other capabilities, the FGP has developed over time a visualization approach using a web mapping framework. This is based on a JavaScript API from ESRI. That code is available on GitHub. It's open code, and you can download it and work with it, and we're there to support you in doing so. We also use ArcGIS Online as a collaborative mapping environment for folks to get together working within a community that they build in a common area of interest, develop their own web maps and then apps, and publish that to the internet or internally if they choose. So you can think of the FGP Geo Community Cloud as a platform as a service offering. So we're making this available so that those bottom tiers that you've seen probably a number of times in AWS slides, the IS tier and the PaaS tier, those are provided for you on your behalf in a secure way, in a standards compliant way. So you don't have to do the heavy lift of standing that up in your own organization. You can leverage this as a service offering. So as I mentioned, Earth observation data has been notoriously, I'll speak on my behalf, I guess I can, since I work for the organization, notoriously difficult to obtain and find in useful formats. However, this is changing. People have identified this as a need. There's a new tool out there. Anybody, you win a, I don't know, maybe AWS will give you a prize if you get the name of this new system that is just readily released in the last couple of weeks. EODMS, Earth Observation Data Management System. So if you used to have an account on NEODF, I can't recall what the acronym stands for, but essentially it was the centralized government source of Earth observation data. If you had an account there, you probably got an email about EODMS. If you use your account, you can get in there and you can see what you have access to. You can download the data and you can work with it if you're a desktop GIS user, or if you're a remote sensing scientist, or if you have other interests and tools and capabilities, you can work with the data that way. What we hope to do is make that more easily available and more easily consumable. Of course, at the same time, respecting the use policies and the legal agreements, et cetera, that apply in many cases to that EO data. So what we're trying to do is make that available, but on the platform. And in order to do that as a service offering, we want to try to enable the capability around temporal use of that data. So there may be people out here in the audience that are working on one of these big policy problems that we are faced with as government today, climate change, the cumulative effects, these kinds of things that heavily are dependent on the temporal or changes over time with that data. So it's incredibly valuable from a research perspective and even a policy perspective to understand what's happened over time, and we want to be able to implement that. Of course, to do that, you're dealing with big data, because it's not just data from today, it's data going back 5, 10, 10 plus years, and then going forward. The other tricky thing about big EO data is, while it's vast in size, I'll talk a little bit about one particular source in a couple of minutes, but essentially what you want to be able to do in some cases is process that data on the fly, because it's very difficult to predict what people may want to look at. There's if you look at band combinations, beam modes, if you look at in the optical spectrum, if you look at different, even just RGB combinations, it gets quite costly to be able to produce that in advance with the guesswork in mind that you will have predicted what the use case is that somebody wants to apply against that value-added product, as they call it. So we hope to be able to do that because we now have technology that allows us to do that kind of thing on the fly. So this is just a graphic that tries to illustrate the current state of affairs. So we have on your right the EODMS and National Air Photo Libraries. Those are two big sources of Earth observation imagery. Right now, there is no common catalog, so you can't go to the FGP, which is supposed to be the one-stop shop for searching and discovering Government of Canada AAA data. Right now, our catalogs don't talk to each other. We need to change that so that people can access that vast realm of EO data more easily. So we're working on that. It's not a big technological problem. We think we know how it's done. There's a catalog service for the web, which is a standardized web service that allows two catalogs to talk even if they're not based on the same technology. So that's in our short-term plan to implement that. We look at that as kind of low-hanging fruit. It's just a matter of getting our teams together. So a little bit, I was told everybody likes a rocket shot, so I had to put in a plug for this. So one of the cool things Canada's doing in the next little while, does anybody know what's going on in February of 2018? We're launching something. Close, half right. It's called the RadarSat Constellation Mission. So this has been quite a few years in the works. We're working together with industry on this project. It's going to be launched from SpaceX Falcon 9 from Vandenberg Air Force Base in February between the 18th and the 24th. I guess they have to allow for some breadth there for weather situations, but I'm going to watch it. I always like a good rocket launch. So RCM, as they call it, it'll be three. It's a combination. It's three satellites in one sort of thing. They're going to release them over a period of time, and they'll eventually be 20 degrees apart. So they're going to cover. They're going to circle the Earth, obviously, and those three satellites will result in 1.4 terabytes per day downloaded, so roughly a petabyte per year. Now, there are some restrictions when it comes to RCM data. However, we will be working to understand what can we offer in terms of making that either a value-added version of that data, which has been processed so that it can be used, making that available through the mechanisms that we've been talking about here today, through a value or a delivery pipeline, essentially. So it's bringing the data from the sensor to the ground station, from the ground station to processing facility. Maybe it's a data lake. Maybe we're triggering through Lambda functions that would then apply to a particular area of interest that would come from a user's request, interacting through a browser, through a simplified application that's got a time slider. You can look at data from periods, as we talked about before, the temporal aspect, and do that all in real time in the cloud, quickly and efficiently. So just in terms of the target state, this slide, it's focused mainly on the catalog side of things. So this is the short term that we hope to accomplish in the next, I would say, 6 to 8 months. And I'll talk just a little bit about the Geo Community Cloud. So where that kicks in, this is an overlying initiative beyond just that short-term work. We have the foundation laid. We did a proof of concept on AWS last year. It ended in the spring of 2018, and that let us demonstrate that we could deploy our core technology stack on AWS and have it work as well, if not better, than it did on-prem in the enterprise data center at SSE. So in the coming year, we want to look at how to implement this on-demand processing and the capabilities that go along with it. In our Esri technology stack, we have multiple products, image server being one, geoanalytics server being another, and ArcGIS server for enterprise being the sort of the main tool. All of those offer APIs, and so we're looking at AWS's API gateway as a way to provide that kind of common place for developers to access the suite of APIs that are available and to build those into their applications without us having to reinvent them or and also making those more easily discoverable in the same kind of catalog search and discovery capacity. So it won't be just about data anymore. It'll be about products that people can find, ready-made things that they can use out of the box, and APIs that they can search, read about to say, yeah, this looks like a good fit. I'm going to try this out, and we can enable people that way. So it's expanding that kind of service catalog. Other things we're open to do with the Geo Community Cloud, we'd like to create an innovation zone. So we'd like to get people together in a space where they can innovate, they can try new things, they can do it quickly and easily, and they don't have to stand up their own secure infrastructure, even if it's cloud, even if you can go to the console and 5 minutes later you've got an instance up and running. Well, you probably want to consider the landing zone considerations, the security considerations. If your organization isn't already doing it, and I bet you they are, you're probably going to have to fit into their way of doing things. So this is perhaps another option that we could explore together going forward. These are some of the tools that we're using from AWS in our current state. I won't go through those, but I think all the thanks to Randy, who's here in the audience, for putting this together. It's got all the cool AWS service logos or icons and everything. And this is kind of our current target conceptual architecture. And I talked a little bit about how we fit into the bigger picture. So this is kind of a look at the components and the layers that are integrated in the overall solution stack. And you can see a dotted line there, so we're integrating with things that are currently deployed. We're integrating with components that our CIO and security branch is putting together. So there's components in there like IAM that we don't want to have to reinvent. We want to leverage stuff that's either in place or will soon be in place. So we're not trying to reinvent and do everything ourselves. We're working as partners. This is kind of a common, it should be a common theme across government. We're certainly, we're full in support of that approach. So that's all I have, and Stephen, I'm happy to take some questions afterwards. Thank you.